Good afternoon, class. Today we'll be doing waves. Now, last week we introduced the topic wave. What do you know? What do you think is a wave? I'll give you a moment to think, and then I'll ask you questions. Great. What is a wave? Okay. Now, a wave, we can classify a wave as a disturbance in space-time or a disturbance in matter without actually moving the matter itself. Because let's think of this. When you have like water waves, right? That's a type of wave. Now, when the water moves, again, it's moving the matter and it's a disturbance in space, but it's not actually carrying the matter like to a different location. Because it's moving, while it's moving, but it doesn't change the fact that the matter is there. Good, so copy that definition in your book. Wave is a disturbance in space or time. Now, when doing anything, we know that there are two types of that something. For example, well, not two types exactly, but there are different types. For example, let's say pollution. You have different types of pollution. You have land pollution, air pollution, water pollution, and etc. It goes on. Now for waves, it's the same thing. You have two types of waves. Those two types of waves are transverse and longitudinal. Good. Now, transverse waves, they oscillate perpendicular to the motion of that wave. What do we mean by perpendicular? Now, this here is what perpendicular means. It basically means that contact is going to give you a right angle to the movement of that wave. Now, let's think of a body of water, for example. When you hit the surface of the water, it oscillates 90 degrees because you're hitting it like this, coming down, and then the waves are moving outwards. So it's technically, when you hit it like this is a downward force, and outward force is basically those ripples that you see going on. Right? All the way around. Going up. Those ripples are what we are, or that's a prime example of transverse waves. Now, copy the definition of transverse waves. Transverse waves are waves that oscillate perpendicularly to the motion. Great. Now, longitudinal waves. Longitudinal waves is all waves oscillate, but longitudinal waves, they oscillate parallel to the motion of that wave. Now, what do we mean by parallel? Parallel are two straight lines that moves, but they never touch each other. For example, sound waves. Sound waves is a prime example of longitudinal waves. Because as we know it, we all hear about music. We're teenagers. You guys basically live around music, and music is basically part of your life at this point. Now you know to yourself, let's say a box is here, that you would hear the song coming towards you. Now that song, those sound waves will never touch each other, but they keep on moving. For example, let's say this is your box. Now they will keep on moving, but they will never ever touch each other like this. You will never find them touching each other. They will always move parallel to each other. Copy the definition for that. And the example. So remember the example for transverse waves is a water ripple, and the example of longitudinal waves are sound waves. Great. Now, the task for you when you roll. Your task is to tell me some examples of transverse wave and longitudinal waves, and explain to me why those respect the law of transverse and longitudinal waves. Good. That's it for today. We will meet next.